Today we will be covering lesson 27-2 on completing the square to find the center and radius of a circle. This lesson will be split into two separate sections. The first section will cover questions 1 to 4. The second section will cover example A. Let's go ahead and take a look at the introduction for 1 to 4. It says, when an equation is given in the form x minus h to the second power plus y minus k to the second power equals r squared, it is easy to identify the center and radius of a circle. But equations are not always given in this form. For instance, the path of a windmill is more realistically represented by a more complicated equation. Suppose the path of the windmill is given by the equation x squared plus 6x plus y minus 2 to the second power equals 16. Describe how this equation is different from the standard form of the circle equation. Well, this equation is not in the x minus h squared plus y minus k squared equals r squared format. The x terms are not a difference of perfect squares. It says in algebra, you learned how to complete the square to rewrite quadratic polynomials such as x squared plus bx as a factored square. The process for completing squares is depicted below. You have x squared plus bx goes to x squared plus b divided by 2 squared, which goes to x plus b over 2, x plus b over 2 plus b over 2 squared. It says to complete the square, keep all terms containing x on the left. Move the constant to the right. If the x squared term has a coefficient, divide each term by the coefficient. Divide the x term coefficient by 2 and then square it. Add this value to both sides of the equation. Simplify. Write the perfect square on the left. Okay. What term do you need to add to each side of the equation? X squared plus 6x plus y minus 2 squared equals 16 to complete the square for x squared plus 6x. So it asks the second step states, if the x squared term has a coefficient, divide each term by that coefficient. Does x squared have a coefficient? No. Now it says divide the x term coefficient by 2 and then square it. Add this value to both sides of the equation. What is the x terms coefficient. 6. So it says divide that by 2. So 6 divided by 2 is 3. And then it says square that. So what term do we need to add to each side of the equation? Well, what is 3 squared? 9. So we would do x squared plus 6x plus 9 plus y minus 2 squared equals 16 plus 9, because it says add to both sides of the equation. And again, that was the x terms coefficient divided by 2 and then squared. It says complete the square and write the equation of the form x minus h to the second power plus y minus k to the second power equals r to the second power. So we're going to have we said we were going to add 9 to both sides, right? Well, if I complete the square and I rewrite this in the original equation format, this is going to be x plus 3 to the second power plus y minus 2 to the second power equals 25. Now, we know that this is x squared. We know that this is now 9. And we know that this diagonal is 6x. Well, we want it to be a perfect square. That's the reason why we completed the square. Okay? What number times itself will give me 9? 3. 3 times x is 3x. X times 3 is 3x. And if I combine these, that does indeed give me 6x. The 3 came up somewhere else as well. That was the number that we got when we divided by the 2. That was that square, that number that we squared. It says, make sense of structure. Identify the center and the radius of the circle represented by your equation in item 3. If I really wanted to get more specific, what number to the second power is 25? What number squared is 25? 5. So my r is 5. Which is important because we want to identify our center, which is identified by HK. Well, my H is -3. Because remember, the equation calls for x minus h, and since it's positive, it's actually minus a -3. And my k is 2. This is my h. This is my k. We know that my r, the radius, is 5 units long. So center is at negative 3, 2. Radius is at 5. On to the next set of questions.